Firefly Aerospace, a US-based startup known for their small satellite rockets, has, under contract from NASA, developed a lunar lander. Named Blue Ghost, their first lunar lander successfully touched down on the near side of the moon in early March 2025. The lander operated for 14 days during the lunar day. Once the sun set, the lander batteries quickly depleted and the mission was declared over on the 16th of March 2025. This achievement marks the longest commercial operation on the moon to date. Blue Ghost Lunar Lander, or Ghost Rider, recap. After launch on the 15th of January 2025, Blue Ghost took 45 days to travel to the moon. The first 25 days were in orbit around the Earth, checking out the onboard systems and waiting for the moon to align for a fast transfer. Travelling through cislunar space only took 4 days before arriving in the vicinity of the moon. Over the next 16 days, its lunar orbit was gradually circularized and lowered in preparation for landing. Touchdown occurred on the 2nd of March 2025 near Mons La Trielle, within the Mare Crisium Basin on the near side of the moon. The lander featured a low centre of gravity, shock-absorbing feet, and a wide footprint for added stability. The landing itself was very successful. The lander executed 2 hazardous avoidance maneuvers during descent, showcasing the effectiveness of the onboard autonomous navigation software. Powered by 3 solar panels supplied by Rocket Lab, the lander generated 400 watts of electricity. It operated successfully throughout the lunar day and even endured 5 hours into the lunar night, gathering valuable data on the harsh conditions faced by solar-powered landers in that environment. A key finding from the mission was that lunar temperatures affected the lander differently than predicted by existing models. This discovery offers a chance to refine lunar temperature models, potentially improving preparations for future missions. Payloads. All 10 NASA payloads met their mission objectives, returning a total of 51 gigabytes of science and technology data to NASA. Some of the achievements included tracking GPS signals from the moon's surface and drilling deeper into the lunar soil than ever before. Lunar regolith, that is lunar dirt, dust and debris, was successfully collected and sampled. The lunar sunset was also observed on the 14th of March with what remained of battery power, as darkness enveloped the surface and the lander. Blue Ghost Mission 2. Starting with Mission 2, which is scheduled for 2026, the Blue Ghost lunar lander will debut Firefly's 2-stage spacecraft configuration. The lander is stacked on top of their ultra-dark orbital vehicle. This orbital vehicle, or space tug, will enable Firefly to deploy payloads and conduct lunar operations in orbit and on the far side of the moon. This demonstrates that space tugs aren't just for low Earth orbit. They can be used throughout the solar system, as we see with this second mission from Firefly. Firefly is developing a range of Electra orbital vehicles, named Electra Dawn, Electra Dusk, and Electra Dark, each designed for different in-space operations. The Electra Dark is the most capable version, designed for long-duration transfers to cislunar space and beyond. It's designed for a long lifetime and can act as permanent orbital infrastructure, in this case relaying communications from the moon's surface back to Earth using its powerful X-band antenna. In the Blue Ghost Mission 2 configuration, NASA's Lucy Night Telescope sits on top the stack, remaining attached to the Blue Ghost lunar lander to measure radio emissions from the lunar surface. While on the moon, the lander supports multiple payloads by providing data, power, and thermal management. The Lunar Pathfinder satellite, a rideshare payload from the European Space Agency, will detach into lunar orbit to enable communications for future lunar missions. At the base of the stack, the Electra Dark vehicle acts as a transfer vehicle delivering the payloads to lunar orbit, where it will stay to offer long-haul communications and calibration services for both Blue Ghost and the surface instruments. Alongside the Lunar Pathfinder and Lucy Night Telescope, the lander carries a seismic payload from Fleet Space, funded by the Australian Space Agency. This instrument will record seismic activity, known as moonquakes, for 14 days, offering valuable data on the moon's geological properties and mineral composition, including potential water ice. These insights could support lunar operations and provide resources like fuel and water for a future lunar base and NASA's Artemis manned missions. But that's not all. NASA has contracted a third Blue Ghost mission, Blue Ghost Mission 3. The payloads flying on Blue Ghost Mission 3 will investigate the unique formation and composition of the Gruithusian domes, with a focus on the Gamma Dome. These investigations include mapping the geological features of the domes, searching for potential water, characterizing planetary, solar, and galactic radio missions on the lunar surface. The data gathered will improve our understanding of the Moon's history, support future human exploration, and provide insights into the past of Earth and other planets in our solar system. Okay, that's it for this video. Thanks for watching. A quick note. In the next few weeks, I'll be hosting a live stream to recap my most recent videos, answer any questions, reply to comments and chat messages, catch up on any overlooked news, and give a sneak peek of what's coming next. It'd be awesome if you can join me. Keep an eye out for more details. Be sure to like and subscribe so you'll see our upcoming videos. We make videos every week covering the space industry with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.